Assalamualaikum warahmatullahi wabarakatuh. I am Latifah Muhammad Noor. In this video, I'm going to explain to you how to answer practice 2.6 page 59, the question which is related to Dalton's law of partial pressure. This is General Chemistry, TST 0914. So a mixture of O2 and N2 in a 200 ml vessel exerts a pressure of 0.953 atm at 30 degrees Celsius. If there is 0.0020 mole of N2 present, what is the mole fraction of N2? What is the partial pressure of N2 in atm? What is the partial pressure of O2 in atm? And how many moles of O2 are present? Okay, the information that we have are the type of gas, O2 and N2, and then we have the volume, 200 ml vessel, the P, which is the P total, 0.953, and the temperature, which is 30 degrees Celsius. We also have the mole of N2 present in the mixture of the gas. Okay, so A question asks us to find the mole fraction of N2. So to find the mole fraction of N2, we need to know what is the total number of mole of the gas mixture. Okay, therefore we can use the PV equals to nRT, okay, to find the value of N total. Okay, because you have the information about the volume, the V total, and also the P total. So this is the P total and this is the V total. Okay, so before we can use PV equals to nRT, make sure you change the unit for volume. Okay, we have 200 ml, so it is equals to 0.2 liter. Okay, and then for temperature, it must be in Kelvin, so 30 plus 273.15, we will get 303.15 Kelvin. Okay, after that, you can start using PV equals to N total RT. Okay, we want to find the N total. So what is the N total? So P, substitute 0.953 atm. And then the V, 0.2 liter, okay, over 0.08206 liter atm per mole per Kelvin, and the temperature 303.15 Kelvin. Okay, so we can calculate the N total. Okay, and then the N is the mole, so L cancel with L, and then K cancel with K. Okay, and then the N total is equals to 0. Okay, the answer is 7.6619 times 10 to the power of negative 3 mole. Okay, so this is the N total. Okay, question asks us to find the mole fraction. So what is mole fraction? So mole fraction of N2 is equals to number of mole of N2 over the number of mole total. Okay, so from there, we can just substitute 0.0020 mole of N2 over 7.6619 times 10 to the power of negative 3 mole. So it gives us the mole fraction of N2, 0.2610. Okay, next. How to find the partial pressure of N2 in atm? Okay, we have seen just now. Okay, we have the P total. Okay, let me highlight it. Okay, this is the P total, which is 0.953 atm, P total. Okay, and then we have also calculated the mole fraction of N2 just now. So the mole fraction of N2 just now we get 0.2610. Okay, 0.2610 mole fraction of N2. So by using the formula Pn2 equals to Xn2 times Pt, okay, we can just substitute 0.2610 times with the P total 0.953 atm. Okay, therefore we will get the answer for the Pn2 equals to 0.2487 atm. So this is the partial pressure of N2. So how to get the answer for C and D? Okay, it's about oxygen now. Okay, so what is the partial pressure of O2 in atm? Okay, we have discussed just now the P total is 0.953 atm, and we have already calculated the value of the partial pressure of N2. Okay, therefore we can use the formula for C. Okay, P total equals to Pn2 plus PO2. Okay, so we can just substitute the P total to get the PO2. So PO2 is 0.953 minus 0.2487, which is the partial pressure of N2. So from there we will get 0.7043 atm for the partial pressure of O2. Okay, how about question D? So question D asks us how many moles of O2 are present. Okay, if you remember, in A, we have already calculated the N total, okay, which is equals to 7.6619 times 10 to the power of negative 3 mole N total. And we also have the N for N2 values given in the question, 0.0020 mole. So from here, N total is equals to N for N2 plus N for O2. So you can just minus to get the NO2. So NO2 is 7.6619 times 10 to the power of negative 3 minus 0.0020 mole. Therefore, the answer will be 5.6619 times 10 to the power of negative 3 mole of O2. Okay, that's all. Thank you.